So welcome everybody to ficonTEC's mini webinar series. We're going to go through the usual items as we usually do first of all. So we have a giveaway that should be something in front of the table, in front of Torsten on the table in front of him. It's
Very
going
useful.
to be the usual. Oh, it's a couple of items, right? Thank you. The question today is on the subject of Lidar. Back around, well, a number of years ago, there was a challenge that was initiated to promote the use of optical technologies for autonomous vehicle development. What I would like to know, and write your answers please into the chat, what was the name of that competition and in what year did it first take place? Put your answers into the chat, please, and then we will see if somebody can come up with the right answer. Okay, next slide. Thank you, Kevin. You beat me to it. So the news for this week is that we have just very recently delivered a custom line CL1500 system to the ORC. So that is another optical research center, but this time at Tampere University in Finland. Our relationship with the ORC goes back, I think, some 15 years. I don't actually happen to know what was delivered over the last few years previously to the ORC, but I do know that this custom line CL1500 has been acquired for lens assembly, fiber assembly tasks, and is there to help develop their integrated photonics technology in the region. And for other partners and associates they are working together with in various EU projects. Torsten, do you happen to know what was given to the ORC in the past? Was it maybe bond line systems?
Yeah, mainly.
Okay, good, thank you. Kevin, next slide, please. So the webinar series, we are going to be looking at advanced automation for Lidar today. We were due to look at high volume manufacturing. We have an answer in the chat. Excuse me, just a second. That's not quite what the name was, and neither do I have the year, so maybe you can try again. Coming back to the topic, so we are looking at the last webinar of 2020. We were going to be looking at high volume manufacturing. We have opted to postpone that topic simply because we do not have all the information we need. We could not have given you the full package. We don't want to give you any half-baked webinars. It's much better if you have the complete picture of how we are active there and with whom. So that topic has been bumped to sometime early in 2021. And we have the substitute topic of automation of assembly processes for Lidar today with guest speaker Torsten Warenkamp. We will be continuing in 2021, and I'll come to the schedule at the end of the webinar. Next slide, please. Again, very quickly, some of you will have seen this slide already, some of you have not. For the newcomers today, what is the goal of this webinar series, again, moving into 2021 as well? It is to maintain a dialogue. It is to keep an open channel to customers, existing customers, and potential customers, so that we can keep a flow of information running to them on a more direct line rather than through the usual industrial social media channels for what is happening, what we are focusing on, and what our systems can do. We try at least to keep these webinars short and bite-sized, 20 to 30 minutes. This means they are guilt-free. And because it is a repeating series, then it is agile and we can try to up our game with successive webinars. What you will see in these webinars is we will bring you some news and developments. Obviously, we will be discussing products or technologies, today Lidar, and if there are questions in the pipeline coming through the chat, then those questions will either be answered during the webinar or we will try to address them towards the end with sufficient answers. If we can't answer your questions today, we promise to come back to you. Next slide, please. So we're going to start with a very quick overview of ficonTEC, what ficonTEC has to offer in general. Next slide, please. ficonTEC is the leading supplier of machine systems for photonics assembly and test tasks. We have been doing this for 20 years. These tasks are effectively align and attach and test and qualify operations that are required in photonics assembly and test manufacturing, be that for R&D, be that for process development, be that for prototyping, new product introduction, or for high volume manufacturing. These processes, I won't go through these, they are listed here. You can find out more on our website. We have been doing this for 20 years. We have 900 systems in the field. I think it's fair to say we have the breadth and depth to help maybe solve your potential problem. Okay, Kevin, next slide, please. I'm not going to go into any detail on this, and on the next slide, this is quickly to show you the 3 platform types we offer. We offer systems for entry-level, systems development, so for R&D, for process development, at a base level, if you like, and of course, then for more complicated R&D or NPI or high-volume manufacturing tasks, or for batch manufacturing. Then we have standalone systems and we have inline systems. The inline systems were introduced just over a little over 2 years ago. These have been designed very much more for modern manufacturing requirements, and is the choice of housing format for many applications moving forward. We do still sell a lot of the standalone formats because they are very popular, and they are in particular formats for custom line, then that is the system that just has been used for some time.
Inline systems are important for LiDAR manufacturing because that's something which we see increasingly in the automotive industry.
Well, I think the important takeaway here is that for LiDAR, we are going to be, if you look at the market projections, we are of course going to be looking at high volume manufacturing rather than single systems or low digit volumes. Yeah. And maybe not even batch, right? So high volume manufacturing inline is really the way forward. Okay, we have an answer in the chat, but it is still not the correct answer. I need to know what was the name of the challenge. There we go. I've given a hint away already. In the States, in the desert it was, and we have a suggestion for the year. That is not the year that I saw online. I believe it was initiated even earlier than that. So please try again in the chat to give me the answer to the question. Okay, coming back to the content, machine platforms. This is just simply to show you which machine formats are available in their different designations. If you want more information here, you will find it on our website. If you have any particular questions or something is unclear, please do get in touch. And we will make sure that you get the answers you seek to help solve your problem. Kevin, next slide, please. We'll make a very quick overview of LiDAR technology. Effectively, Kevin, next slide, please. There are any number of sources online, even with the particular technology developers, that give you extreme detail of what these different approaches are doing and what they're trying to accomplish. We will not try to cover that ground in that webinar. It makes no sense. What is important, I think, and I think you wanted to make an important point here, Torsten, is with regard to the suite of technology approaches we see here.
We see pretty much all of them right now built on our machines, whereby the trend is clearly the solid state, non-scanning, you call it staring systems, and the optical phase arrays. But even on the long range LiDAR systems, the oscillating MEMS mirror is a very important part of this. And is that it's a huge variation of LiDARs we see on our machines, but is that an increasing number now optical phase array based.
And we will cover this again a little later in a little more detail, but I think the important message here is that the OPA approach is more long term. So we're maybe seeing a little more R&D being done in those systems for the systems that are on the horizon, whereas the flash technologies are certainly perhaps a little more current. Is that correct?
Yeah, correct. So that's
okay.
I would say more to production today.
Okay, good, thank you. So moving on to the next slide then, please, Kevin. Again, not going in any particular depth, we are seeing a range of light projection and associated image acquisition approaches associated with our systems, or associated with the use of our systems. What is important here is that we collected the toolbox that feeds into the LiDAR technology space before LiDAR came along, together with telecom, together with imaging systems for camera modules, aligning those systems, putting those systems together, aligning fibers to lasers, laser arrays to optical elements. This is something we have already done in the past. Our toolbox is already available to address the LiDAR technology space. What is different here is that we have this combination of projection of light and the associated image acquisition. And those two systems need to be looking at the same point in space. The three aspects that are mostly relevant here is all of these systems are using laser sources. So they're using the associated optical elements or arrays of both. These projection and imaging systems, they all require an interesting mix of highly precise align and attach operations, with some test and qualify operations to follow, of course, as well. And even if we look to the approaches that are a little bit more on the horizon, so OPA or frequency modulated light projection approaches for LiDAR that give you more depth in the reflected information coming back. Again, there is no real change here. This is light projection. But what we are seeing, and I think this is correct, Torsten, correct me if I'm wrong, we're moving, of course, to the integration of MEMS and PICs components that are already used in the, or the type of component that's already used in the communication space.
And especially we see completely different environmental stability criteria. So that's definitely where the datacom components, where we're mainly active, or the high power laser devices. The requirements on the automotive sector is for the LiDAR devices are much tighter. We cannot necessarily work with the same epoxies, with the same bonding components or methods we have worked in the other areas before. So there's a fundamental change in that area. But in general, okay. The active alignment side, it's fairly the same.
Okay, so I guess the general takeaway here is that the challenges arise in terms of addressing the required performance, the alignment of the two optical systems, and then also in the specific assembly tasks associated with that particular application space. So LiDAR, for example, for automotive. But as we will see, LiDAR is not only for automotive. Kevin, next slide, please. So I'm not going to spend any time here. This is an overview provided by Yole Development in one of their recent online webinars, or where they contributed to some online technology meeting, I think, where they illustrate where the different players are with regards to the different technology approaches. We can't tell you here who we are involved with. What we can say is certainly for the components that are being used in some of these technology approaches, we have the situation that we have for many years already, we have already been using at least the common types in terms of detector or light puts or light outputs arrays, in terms of VCSELs or individual laser devices, arrays of optical elements. So what we have here is we have a situation where not only are we involved directly with the LiDAR space and the LiDAR technology development, we also have the situation where we have a catalog of know-how of how to deal with these components in terms of assuring performance, how to handle them, how to integrate them ideally into certain constructs, into certain modules. And we can, of course, bring this to the table to a discussion with a potential customer when defining the system and the system specifications.
No, it's definitely that we made a step upward in the food chain. So we're serving now in the LiDAR space, we are serving the customers of our customers. So we're building and qualifying devices which are now used in that newer space of LiDAR. where we kind of assembling that devices, which we worked already before, into the LiDAR devices.
Thank you. Kevin, next slide, please. And again, we won't be spending any time on this slide, apart from to highlight the fact LiDAR is not just about automotive. I think if you look at any of the manufacturers on the previous slide, it is pretty clear they're going to be, or it's pretty clear that they are already employing different technologies to be used in different application spaces. And I think an important takeaway here is that not all of these have a time to market trajectory that is the same as automotive. They will have different requirements, have different specifications, and we will see these different application spaces being addressed by LiDAR either in a shorter time frame or even eventually in a longer time frame. And I think we are also affected.
Hopefully not, no.
Not yet. I think we are also directly affected here as well, Torsten, is that correct?
Yeah, so it was a very interesting move recently. So for one of our largest customers, we have already a number of machines which work in sequence, like lens attach, fiber array attach, TX site, RX fiber array attach. And these the modules need to travel from machine to machine, but it has to move into different stations between our machines. So up to now, it was always the case that the operators were moving cassettes of devices from machine to machine. Now we see that we can use LiDAR or automatic robots between that machines, which move the cassettes from machine to machine, and they are actually having a LiDAR on board in order to scan the environment. So I found that very interesting. Now that we use to drive our machines, we need even LiDAR systems.
And I think if you go to any of the technology players listed on the previous slide, or even the ones that are listed here, those application spaces will also be listed on their marketing collateral.
Yeah.
What is interesting, of course, is that if you take any of these applications, then the forecast growth in terms of units delivered per year from 2020 onwards is anything up from 25% upwards. Some of them even forecast to be 100. So these are truly, at least in the short term, forecast to be hyper growth application areas.
While we speak right now, there's this big LiDAR conference in China. It was yesterday and today, and there was a huge amount of interest from different areas, and there was by far not only automotive LiDAR systems, a lot of sensing devices.
And globally, I think as well, right? There was interest from outside of China as well from that event in China. So moving away from the topic very quickly, yes, we have a winner. Thank you, MMK. I believe that is Maureen. It was called the DARPA Grand Challenge, and it was initiated in March of 2004. So I believe that is the second time that person has won something. Somebody's paying attention, somebody's doing their homework. Well done. Thank you for your participation. You're welcome. Okay, Kevin, then next slide, please. So coming back to the topic, what is it that ficonTEC, what is it that ficonTEC can do for LiDAR? Okay, finally. I think the most important point to highlight is that there are a couple of aspects to LiDAR that one needs to appreciate. One, it is not already the perfect device. It's not probably ever going to be the perfect sensor. And an important aspect to LiDAR is certainly in the automotive space, what we are looking at is we are looking at a data merge between maybe up to 8 different sensor types that will be employed either in parallel or in various different locations around the vehicle. And it is artificial intelligence that will be merging this data, and it will be the performance of that AI system that determines the ability to identify objects at range and at speed in a moving vehicle. Having said that, naturally, there are some aspects to the align and attach assembly tasks that affect the performance of those systems. For example, range, accuracy, resolution. I've said this already, both optical systems need to be addressing the same point in space. This helps to minimize crosstalk. If those systems are not coaxial, then there are 2 optical systems that need to be aligned, of course. And in a situation where you want to maximize your range, 300 meters and above, then it is very important to get that task correct. So there will be test and verification steps associated with the devices that roll out of our machines. Another aspect, of course, excuse me, is that in the progression towards solid state systems, this is a change away from moving parts. This contributes to system longevity and also to robustness. Does it actually make a change to what we do, Torsten, what our machines have to provide?
Definitely. So the machine type of this different sensor devices have an impact on the way how the assembly machine looks like, and we see a progression into the direction of more the semiconductor type. So, but the form factor right now is still fundamentally different from this different sensor types, and that has an impact on the machine itself.
So I guess what you're inferring there is that we have a blog post that refers to device assembly convergence. So the greater use of integrated components and processes associated with that that maybe simplifies the assembly process, but doesn't simplify the device in terms of its performance expectations.
Correct. Yeah.
Thank you. Then one last point on this slide is, don't forget, of course, that the artificial intelligence system that is going to be running behind all these sensors and merging the data, artificial intelligence algorithms require data. So I think it's pretty safe to assume that the leading players in this technology field that have the most number of kilometers on the road with their systems are probably the ones who know where the gaps are in their hardware technology and what the hardware needs to accomplish so that they can achieve the goals they want to reach in any particular application space. Okay, next slide, please. So coming back to a little more detail about what the tasks are. I mean, effectively, they are listed there on the slide. We are looking at align and attach operations for the projection side. We're looking at align and attach operations and a fair mix thereof, I think, as well, for the imaging acquisition side of the Lidar sensor. Those two projection and imaging systems need to spatially overlap at the region of space you want to look at. What this effectively means is that it reduces to a complex, but it reduces to a common set of what are already highly automated, already well-known, tried and tested hybrid assembly processes that we have already gathered over the years. And the challenge in each particular case is, as we have already said, is addressing exactly what those requirements are in that particular application space.
Which is definitely a difference in terms of form factor, the components or the material we use to bond the devices. We have to handle the fibers. They are attached differently to that modules if you have phase shift arrays. So there are challenges, but the basic functions are always the same as we do for telecom, datacom, and high power lasers. Next
slide, please. Looking towards the horizon, we've touched on these already. OP, optical phase arrays, do we see any challenges here?
It's very close to what we are doing for the photonic integrated circuit industry already for telecom, datacom. That form factors, again, they're different. The fibers and fiber arrays, they have to be polarization maintaining. It's a different prep work for that activity. Fibers are usually longer, so we don't see components with connectors right now, or at least not the connectors at the device level. So there are different ways how we have to prepare the material before it goes into the machine, but in general, it's the same as we do with other industries.
I think it's fair to say that we can consider an OPA to be effective. It is an array format. It is equivalent to another optical element array. In that respect, we are agnostic in terms of being able to place and attach that system. Obviously, we need to pay attention to what the performance needs to be, how that needs to be coupled to the light source or multiple light sources maybe. But I think technologically there's no challenge there. And what about the transition to peak integration, so towards the communications wavelengths? There is no real change there either, I guess.
Correct.
As already mentioned, then of course we still need to address the situation of post-assembly testing of the assembled devices that roll out of our machines. But of course, we are not a tier 1 supplier. We have to meet specifications that are given to us, but we don't have to package these things for ourselves for the automotive application. Where are we, do you think, in the development chain? Where are our systems mainly being used, and how soon do you see high volume manufacturing lines?
We have first customers who are kind of ordering multiple machines in order to go to a higher volume production. But a lot of our customers are currently still in the final phase of their NPI phase. So shortly before the production launch.
Okay.
What is different, especially in the teams we're working with, usually in the telecom, datacom, and the high power laser space, we are usually talking to experts in optical, with an optical background. In the Lidar space, we are working mainly with people who are coming from the electronics background. So the knowledge, the skill sets we have to bring and the customer is bringing is different. And so it's a different type of working together.
Okay, so there's a lot for them to learn as well, and they are coming up to speed on what a photonics assembly and test can actually do for them.
Yeah.
Do you think that has been instrumental in acquiring the customers that we have gathered already?
I think so, yeah. Knowledge to the table in that space, in order where we can also do consulting for these devices. Okay,
good, thank you. One last point here on this slide is that we should add that we have been aggressively pursuing die level and wafer level electro-optical testing. So at the point where LiDAR technology moves to high volume manufacturing, we should be in a strong position to properly tackle any requirements for test and verification of those devices as they roll out of our machines.
And we do that for a sensor already, where we have an end-of-line test. It's an inline system where we do end-of-line, kind of a pressure test and a final laser marking process in that line for an automotive customer.
And I think that is exactly the topic that we want to bring in our high-volume manufacturing webinar early in 2021. Is that correct?
Correct.
Okay, then next slide, please. This is an overview of the type of passive active automated assembly processes and which systems I think that can be employed within the LiDAR application space, in particular looking at the transition from R&D and innovation over to NPI, so new product introduction, and onto high volume manufacturing. Then we have that breadth of machine system offering to cover each of those requirements. A key takeaway here is that if you talk to the automotive manufacturers, then, or if you listen to the automotive manufacturers, then they have pushed back their release dates for level 3, 4, 5 autonomous vehicle implementation several years. And I think over the next few years, we're going to see maybe in different regions of the world, different rates at which LiDAR technology is taken up. Certainly there are some parts of the world that are very litigation happy, where maybe there needs to be a much stronger basis in terms of what the systems are allowed to do, what they are responsible for, and what the driver is still remaining for. But we will see that progress and how that develops over the next few years. Next slide, please, Kevin. Here on this slide, I won't spend any time here, but here I highlight the different machine systems that are usable in a LiDAR, excuse me, in the LiDAR implementation. And again, if you need any more specific information here, there are a number of sources. I will refer to these at the end of the webinar, and you are, of course, sincerely invited to get in touch directly. That's probably the best way to get the best answer to any particular questions you have. Next slide, please. In terms of high volume manufacturing, and this is something we touched on I think in the very previous webinar 2-3 weeks ago, what is involved, what are the considerations we need to bring to the table when considering volume manufacturing? And I don't think these really differ for any of the application space where our machine systems are used. So they are, what are the manufacturing requirements? What are the performance requirements for the device? And ultimately, of course, what does the throughput need to be? And how can that be addressed in the individual machine systems or in the product line that's put together? Those different budgets refer to, for example, in Lidar, what is going to be the cost of producing the device versus the device, the price at which that device is going to be sold. In terms of performance, we need to make sure we hit the specifications in terms of range and resolution, field of view, etc. And this is also related to how many channels are involved in accomplishing that specification and what the total process time is associated with the assembly and testing tasks required to put that module together. And in terms of throughputs, very much is the same arguments, but again, we need to look at what particular processes can be used in achieving those throughput targets, how that production line needs to look like, and whether we are talking about batch production. I think that is the suite of systems that Torsten mentioned in a previous slide a few minutes ago, versus a fully inline production line system designed for high throughput. Next slide, please. This is just a simple video illustrating what the custom line system can do in an R&D and in a development environment in terms of alignment and lining up elements over filters for telecom applications, and also for, I happen to forget what this was. We had this video in a previous webinar. This was the system that went out to the Fraunhofer HHI, so the Heinrich Hertz Institute in Berlin. And this system can be used for a suite of applications, for a suite of assembly and align and attach tasks involving MEMS, sensors, biomedical devices, etc. And this system has been used by various R&D institutes around the globe for communications, Lidar, camera systems, high-power laser diodes, etc., etc. If you want to find anything more out about the system, then please go to the previous webinar on bond line and custom line. And of course, we can answer any questions directly.
But it's pretty much an integrated or a kind of a concentrated version of everything what we have done in our 20 years history. So all the functions can be integrated in one machine. That's our, in German we say eierlegende Wollmilchsau. This is the animal which gives wool, milk, eggs, lays eggs. So it can do everything.
Right. So the English expression would be all singing, all dancing. This is a wide body housing format where we're in the position to include a large number of different process modules for the accomplishment of a wide range of different align and attach, and even test and qualify tasks as well. Next slide, please, Kevin. So in terms of pushing the assembly task envelope, I think what I want to draw your attention to here is that we've already touched on the fact that some of our systems are being used for unique optical elements. We had to learn in some instances how to, we did not need to learn how to align and attach these in terms of the attach process, but we had to learn for particular optical elements how to best handle optical elements. We are also in a situation where we have to align all elements in an array. If you may remember back to the passive versus active webinar, we learned, at least for fiber ribbon and for other array applications, sometimes you can get away with just aligning the two fringe or the extreme elements, and the tight tolerances in the manufacture of the array then suffice to make sure that everything else is aligned. In terms of maximizing range and photon flux at your destination range in the Lidar application space, we find that we are having to align all the elements in an array. Coming back to some of the other things covered in previous webinars that are relevant to the LiDAR development space, machine learning based optical element auto alignment is something that can be used here. That webinar where you can find out more information is listed there. Performance services, so when we make the transition to high volume manufacturing, then ML based process control is something that will also be equally applicable in this field. Advanced automation for PIC integration is something that we have been pursuing, obviously through communications applications for some time already, and similarly to with our involvement and collaboration with various R&D projects in Europe and elsewhere, together with various different institutes in that sector. And through silicon soldering and automated fiber strip cleave insertion are also two other areas I would like to highlight where we are actively engaged in R&D and innovation in activities that will benefit high volume manufacturing of LiDAR moving forward. Okay, Kevin, next slide, please. So that is the end of the topic. We have no questions in the Q&A. Torsten, is there anything you feel you would like to add to the content here? Is there anything we have left out?
No, I just want to emphasize that I think ficonTEC has a skill set to be a partner for the LiDAR sensor industry, and we have a lot to offer for the current and also future manufacturers of these sensors. We are super innovative. If there's new technologies required, we are permanently in flux to develop new capabilities. So just use that and challenge us with new stuff.
That is exactly the point I wanted to make. I think at the end is that we are very keen to get engaged with new challenges that actually push our applications and developments team, so that we can move not just LiDAR but photonics assembly and test as a whole, move it along into high volume application spaces, high volume manufacturing application spaces. So there are still a few more slides here at the end of the webinar where I'm just going to round up. Some of you will have seen this before. What's in it for you? So what is in it for the customer? Very quickly, we collaborate and exchange. So we give and we take information and processes and innovation with a bunch of institutes and partners involved with projects and initiatives that are funded primarily within the EU, but also internationally. So we give and take into and from the ecosystem. We've been doing this for 20 years. As a result of those partnerships, we obviously are in contact with R&D institutes. We also have a suite of international contract manufacturers if you want to outsource any manufacturing. We have a customer base spanning the technology leaders across Europe, Asia, and North America. And I think it's fair to say, Torsten, the same is true at the moment in LiDAR as well.
Yeah.
And
whereby the LiDAR space is still, I think that there's not a lot of information shared between manufacturers, and so everybody keeps it to their chest.
Is there any regional distribution there as well?
Yeah, with the most work we are doing right now for the US and for the Asian areas, not too much in Europe.
Although we do have projects ongoing within Europe.
Majority is US based, yeah.
And again, something I always like to mention, after nearly 20 years and now 900 systems in the field, then obviously we have that breadth and depth. So if you have an issue, if you have a problem, please come speak to those who know or who probably do know, and let's bring our expertise to the table and try and solve your problem. Next slide, please. If you want to find out more information, I keep banging on about these webinars, but we are slowly collecting an interesting suite or data set of information that couple into each of the different topics we discuss. We've covered our product lines, we've covered technology areas, and this is something we will be continuing on with in 2021. For example, we will be bringing you that high volume manufacturing topic that we have promised for so long. If you go to our Vimeo channel, and if you go to our website, then you can find short videos that demonstrate process capability. So short snippets of processes on real systems, no animations, that show you to a degree that what we can do, at least where we can show you that. And you will find some PDFs online that are overview documents. Let's be honest, most of the systems we create are manufactured as custom systems because of this direct application areas or the R&D nature or development nature of the work that's being done. That may change, of course, as we move into high volume manufacturing, but it's very difficult to write a PDF about a moving target. So if you have any specific questions, as I've always said, please come back to us and we will answer your questions directly. Next slide, please. So if you go to the website, then you will find a bunch of links on the right-hand side. These are illustrated on the right of the slide that relate to our ficonTEC Insider blog, to Twitter and LinkedIn, to the Vimeo portfolio, and to YouTube, and also to our locations around the globe if you want to get in contact with us directly. Also, I list here a number of interesting ficonTEC Insider blog entries. Please go to that page and take a look at the contents. And if you have any feedback and if you have any specific requirements, please get back to us. Maybe the last slide, Kevin. This is where we are located around the globe. This is the latest update to our location map. And finally, next slide. Oh yes, not forgetting the schedule in 2021. So we will be resuming broadcasting on the 20th of January in 2021. Again, as always, that will be at 3 p.m. CET. After that time, then we will continue with the webinars on the first and third Wednesdays of each month. If you look at the calendar and work that out, then that means roughly every 2.5 to 3 weeks on average, then we will be putting out a webinar. Those are the times for your local regions. And I think if we go to the next slide, I think that wraps it up for today. Torsten, thank you very much indeed for your contribution. We're getting some good comments in the chat. Thank you for everybody for taking part. I hope that was useful to you. Please feel free to give us some feedback. It is valuable to us and can only make the webinars better through into 2021. Torsten, thank you very much. I hope that was good for you too.
Perfect. Thank you very much. Merry Christmas to all of you and a Happy New Year, and stay healthy over the Christmas break. Thank you.
Yes, very important message. Thank you indeed. Bye-bye.
Bye-bye.